Great pleasure to be here to present the QuarkChain and introduce our latest development. I would also like to thank you, ArcBlock, to co-host this event with us. So we have long conversations since San Francisco, and it's my great pleasure to now be in Seattle. Also our first time to Seattle to have a meetup. And so today I will introduce the QuarkChain, which is the project that aims to address some critical issues in the blockchain. So before I start, let me ask a few questions. So how many of you are engineers? Just raise your hand. Oh, okay, great. And how many of you have cryptocurrencies? Oh, okay, I believe all of you have cryptocurrencies. And how many of you know some Ethereum? Okay, so I assume the rest of you has just Bitcoin. Okay, great.
Or maybe other crypto.
Yeah. Okay. Yeah, great. So let's start. What is QuarkChain? Basically, the QuarkChain aims to address some critical issues in the blockchain. And I would say two critical issues right now exist in blockchain. One is called scalability. Another is basically flexibility. So we know like blockchain actually brings a lot of benefits in terms of immunity, and also in terms of transparency, and also in terms of like widely proof security, and also not to mention the decentralized. But however, like right now, the main issues of blockchain is that they are like suffering from the low transaction per second. For example, like Bitcoin right now roughly can process 7 transactions per second, and also like Ethereum is roughly be able to process roughly 15 transactions per second. And so this low transaction per second like greatly limits the, I would say the applications of blockchain. So the QuarkChain basically aims to address first the scalability problem, which aims to using a new technology called horizontal scalability, which has been well developed in both the big companies, internet companies like Google and Facebook, to address their internet like wide users services. So we are a group of engineers from Google and Facebook, and then utilize actually used to work on their infrastructure, have extensive experience in like designing, implementing, debugging, and optimizing those systems in centralized world. So why actually it is so difficult to increase the scalability of blockchain? Actually, this is basically a problem that actually we call a trilemma, where consider the three major properties of blockchain. One is decentralization, security, and scalability. We actually, a lot of people like agree it's very hard to achieve those three properties at the same time. If we ignore one of them, so for example, suppose we ignore scalability, right now Bitcoin Ethereum has running pretty well. For example, Bitcoin has run for almost 1 decade and offer like a lot of like for example, asset management services. And if we ignore the decentralization, for example, in Google, they have developed called a big table, which serves like I will say billions of users in the world. Another popular distributed system is called Cassandra, which is also like developed by Apache, and also like is able to use it, for example, in Facebook to, for example, Instagram to give service to their users. And if we, for example, suppose we sacrifice security, then we are able to employ, for example, multiple blockchains. However, at the same time, this blockchain can be easily attacked. For example, recently, Bitcoin Go was being attacked because the low hash power that are running on top of the Bitcoin Go, and so this caused like further security concerns of blockchains. So why scalability is so hard? Actually, scalability itself is a core problem in the centralized world. And in the centralized world, like Google and Facebook and other companies have spent decades to increase their scalability. Because the scalability, we know like any factor in the system, networking, CPU, memory, storage can become the bottleneck of the scalability. So from history, we learned that before around year 2000, the scalability is more focused on one solution called vertical scalability. The basic idea is to improve single machine performance by using more powerful CPU, more memory, and more expensive disk. And there are a couple of companies that are famous in this area, like Sun, Oracle, like AMC, which like Sun is famous for its workstation, Oracle is famous for its database, and AMC is famous for its storage. Now, with the rise of the internet, the number of users grows exponentially over time. And so Google and Facebook, they try to build some kind of services to satisfy their user needs. And so they found actually the vertical scalability can easily hit many needs because of the physical constraints of these hardware devices. For example, we cannot have arbitrarily fast CPU. And for some, like disk density is also limited in some space. And so Google and Facebook, they come up with a new solution called horizontal scalability. The basic idea is to build a cluster of commodity PCs and then put it together, and so that they can work together so that they are able to achieve high performance. And once the user grows, then just add more machines into their cluster and build more data centers to put this commodity PC together. And this is how they call horizontal scalability. And the core technology behind that is called sharding. And now we come to decentralized world when we started in 2009, when the Satoshi first launched Bitcoin. And so since that time, a lot of people say, oh, there's a lot of benefits there, but the performance sucks. And so there are a lot of projects trying to improve the performance by, I would say, a single blockchain performance. In other words, we use called vertical scalability in a blockchain. So the basic idea is to change some parameter in a single blockchain. So for example, there are two key parameters in the blockchain. One is the block size, which means the greater the block size, the more transactions it can contain. And another is block interval, how fast a block can be produced, so that more transactions can be performed in a specific time interval. And so for example, Litecoin decreased Bitcoin block interval from 10 minutes to 2.5 minutes, so that they can claim 4 times performance improvement. Pretty simple, one-line change. And so Bitcoin Cash chain increased the block size from 1 megabyte to right now I think it's 32 megabytes. So they can claim 32 times performance improvement. However, these two parameters cannot arbitrarily increase or decrease. For example, I cannot increase the block size to 0 gigabytes or decrease the block interval to several, maybe a few seconds. So in order to basically optimize these parameters, new projects using a new consensus. For example, Ethereum using a consensus called Proof of Work Plus Ghost algorithm. So they can further reduce the block interval from 10 minutes to 15 seconds. And another exchange is called DApps, where it limits the network size, so it only has 21 nodes that are able to produce a block, and so that it's able to even produce a block in sub-seconds. However, I feel in this direction, it's similar, following the same path what centralized world have been done, where we gradually hit the limits, both in terms of networking, CPU, memory, and also in terms of network size. So we projected in the future, suppose we have a blockchain that is able to serve the global-wise business, so that everybody is able to use blockchain anytime, anywhere. Then we are expecting we need some horizontal scalability solutions to a blockchain. And that's how the motivation of blockchain, which is to basically develop called blockchain sharding technology here. And so we just actually launched our basic testnet using blockchain sharding technologies on July the 7th. We have deployed 256 jobs with 50 clusters and more than 6,000 nodes, which we are able to achieve 14,000 transactions per second, which is, I think, roughly 10,000 times higher than Ethereum. And we deploy all these nodes around the world, including US, European, and also Singapore. And we also actually open source our code, which is be able to access from GitHub search QuarkChain, and be able to, for example, like explore how we achieve those numbers using these parameters. In addition, to encourage our developer communities, we have a called TPS competition, so that we offer top 10 winners who is able to, using our source code, and reproduce our numbers, an even higher number, because what we have is just some number that we haven't exhausted in it. So we encourage our developer community to reproduce what we have. It's not only, oh, we can get this number. I would say everybody is able to get these numbers. And for the top winners, we will have 1 Bitcoin award for the team. Okay. And so this is what we have done actually in this recent 8 months development. So our next target actually we are thinking about is that what can we do better in other critical issues in the blockchain. And we believe another critical issue is called flexibility. Why? Because once a blockchain is launched, it's extremely difficult to change a lot of key parameters in the system. For example, consensus, virtual machines, or even ledger or token economies. For example, recently, I think yesterday, I think at the end of last month, so Ethereum proposed a new next platform or next version of Ethereum called Constant. Sorry, it's hard to pronounce. It's Constantinople. Yeah.
Constantinople.
Yeah. And it changes token economies so that every block, its block reward is reduced from 3 Ether to 2 Ether, which brings some, I would say, good news to the Ethereum community so that the inflation rate is lower. And then, yesterday, I think a few days ago, we first applied this ArcBlock to testnet to verify if there's any issue. Unfortunately, it failed. Why? Because a lot of miners, the lack of incentive, so, wow, you are basically reducing our rewards. Why should I join? And it failed, which means that its mainnet launch, which applying these new versions, will be further delayed. It was supposed to be end of this year, but since the testnet failed, because a lot of interest parties they disagree on these changes, and so that it causing this basically this issue. And so every time, for example, Bitcoin itself has a long debate of how to change this parameter to increase the scalability. And right now it's almost fixed. Nobody can change it unless create a hard fork that's backed by sufficient hash power. So we feel there's a lot of things in the blockchain. It's very hard to adopt new innovations, both in terms of new virtual machine, new consensus, and also even maybe new token economies. And this is our motivations for our next generation of blockchain 2.0, which we are expected to launch in the next year. But the basic idea is to still build on top of blockchain sharding technologies, and so that we can be able to using different shards to run on different, I would say, virtual machines, token economies, or for example, even different ledger. And so that we can easily incorporate the state of blockchain innovations. As long as these innovations is vertical scalability, they can easily incorporate. You can imagine that Google, Facebook, besides they develop these large distributed clusters, they're also to be able to buy more expensive commodity PCs so they can increase performance, because performance is kind of the area of vertical times horizontal. And so, for example, here we list some existing blockchains, what kind of, for example, consensus they are using, what kind of smart contract virtual machines they are developing, and also token economies, and what's the purpose of their tokens that are used in the system. And for example, Ethereum basically using Ethereum as the transaction fee and also mining reward, and right now it's proof of work, but it's also proposed to using adopt proof of stake, and they're also going to using probably WebAssembly to as its virtual machine to be more efficient. Another famous probably EOS, which already adopted WebAssembly using called BFTD Plus, and while they are using more tokens to represent different resources in basically in their network. And so basically a lot of these things are just fixed in the system. And for us, we are able to support like different shards using different kind of virtual machines. So suppose we want to add more virtual machines. Basically, there are two ways. One is to hard fork the shard, or we can just add more shards, which is designed for some virtual machine. And also, similar way, we can have done consensus. Actually, we are exploring the proof of stake consensus as our shard consensus, so that it will be more energy efficient, friendly. And also, we are able to customize the token economies. We call a very feature called multi-native token. So that the system is not only just single native token, like Ether or Neo or Bitcoin, but there's a multiple native token. And all of them can offer different kinds of token economies, including inflation rates, including their total supply, also in terms of their utilization scenario. So why flexibility is essential for next gen public blockchain? Because we see a lot of blockchain, they have a very strong burden to move to next directions because they need to maintain network compatibility. Because when they design the system, even for Ethereum, they're very flexible in terms of the DApps. However, when in terms of consensus or even token economies, they have a lot of limitations since they are not designed for these features at the beginning. So for example, here is an example that shows a QuarkChain system that runs multiple shards, where there's a root chain that protects all the shards, while different shards run, for example, for example, the first one runs like a proof of work, like Ethereum styles, like a blockchain. And another shard runs more like a default, which is like a more EOS style blockchain, and others. And so for existing developers like DApps that already built on top of Ethereum, they can easily port their code to the shards that already support Ethereum smart contracts and also a lot of, for example, proof of work account-based model. And for others, for example, EOS applications, the applications can also be deployed on another shard that actually offer the EOS style token economies and also smart contracts. And in addition, in the future, I know there are a lot of consensus, proof of X, I would say A to Z, almost every ledger has somebody proof of something. But a lot of things still in experimental stage because people have no idea what is going to, for example, what kind of security model you can, for example, defend, and what kind of the transaction you can offer. So it takes time to verify these technologies, but we already reserve the seats for them. As long as there's something that is pretty mature and also bring actual benefits and also verified in production, then we are able to easily incorporate these technologies to be a part of the new shard in the system. In addition, one interesting thing we are going to propose is called multi-native token, which we see that a lot of vertical domain blockchain projects, why they need to create a single blockchain rather than they deploy on top of Ethereum itself, just by running on DApps. Because they want to have their token economies as first-class citizen instead of the ERC20, which is just second-class citizen and have a lot of limits. For example, ERC20, in order to make a payment to a smart contract, in general require at least 2 steps, 2 transactions in order to perform this step. While if I use Ethereum, I can just use a single payment and just done. And so those projects, they want to determine, for example, what kind of total supply or what kind of the tokens and usage of these tokens. Besides like just like ERC20, maybe people can just transfer. So we propose these multi-native tokens so that they are able to, for those vertical domain projects, they are able to create their vertical blockchains and determine their token economies and set up their native tokens. And these native tokens will be able to directly use it as, for example, using as a transaction fee, which is impossible for Ethereum. And you can also use a single step to finish the payment. For example, right now I can use Ethereum to finish a crowd sale, just a single step, send the money, and get token back, single step. But now, if I want to use another ERC20 as a payment to finish this, I need to take at least 2 or 3 steps. I need to approve, call the smart contract, and make sure that it works, and then get tokens, and it's really complicated. And also, since we support QuarkChain transactions natively, all the native tokens can be easily liquidized into all shards so that it can benefit from the whole basically token, I would say the whole ecosystem built on top of the whole system. And also there are some benefit in terms of mining. And so this is a summary of our next generation of blockchain, which besides scalability, we are all going to offer more flexibility to the whole system. And so that we are able to embrace the up to state-of-the-art blockchain innovations and able to, for different industries and vertical domains, we are able to better customize their needs. Okay, I think.
And brief question about sharding.
Oh, okay.